Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. Today we are going to talk about how you can use Apache Spark with Amazon Athena service. So let's get started. So we all know that you can use Amazon Athena to perform any types of query or analytics for the data stored in Amazon S3 bucket. Either you have to create a glue catalog table for such data, and then you can use SQL-like queries to perform query or analytics on such data. Now, in addition to using SQL, you can also use Spark to perform similar query or analytics. So in very simple language, in Amazon Athena, you not only use SQL, but you can also use Spark kind of queries or syntaxes to perform any kind of analytics on the data. So the way it works is that in Amazon Athena, now you can also launch a notebook instance, which then can be used to run Apache Spark based statements or commands, which are scripts, which then you can use to perform any kind of query or analytics on the data, which is stored in Amazon S3 bucket and which is cataloged through AWS Glue data catalog. So let's try to, so this might sound like little, I will say, duplicate capability, because it is not Amazon Athena is not the only way you can perform Apache Spark scripting. I mean, if you look at the existing offering from AWS, you have AWS Glue developer endpoints or dev endpoints, which you can use for running Apache Spark scripts. You can use Glue Studio interactive session to run Apache Spark kind of scripts. And now we have got Amazon Athena to run Apache Spark scripts. So how does Apache Spark with Athena fits with other two capabilities, developer endpoint and Glue Studio interactive session? So let's try to understand each of these things a little more detail, and then then I'll give you my personal opinion that how do I see these three services fitting against each other. So if you talk about Glue Developer Endpoint, in Glue Developer Endpoint, you cannot convert your script into a job. So you can run Apache Spark script, but you cannot convert into an ETL job. You have to copy paste, and you have to do a lot of other things to make it into a job. You can write code in the console script. You can do scripting in the console script, AWS console itself, or you can also do scripting in your local machine. So you can use a local ID like PyCharm, which can then connect to developer endpoint, and then you can do remote scripting as well. So that's what you can do in developer endpoint. Now, if you look at the interactive session here, again, one benefit is that you can convert your script into job. So when you're writing your script, once you're happy with the script, you can say, hey, I want to simply create an ETL job out of it, and it can do it for you. And you can also do scripting in console. Well, you do scripting in console only. I don't think there's an option to do any remote development with Glue Studio. So the only way you can do development is you come to AWS console, and then you simply use Glue Studio to do the development. So I already talked about interactive session-based development in some other tutorials. If you're not aware of this particular feature, you might want to look into that tutorial. And now I have got Apache Spark, now where you cannot convert your script to job. So again, you can write your script, but then end of the day, if you want to convert that into job, then you have to do copy paste of the code and do other configuration to convert that into a job. And in this case, again, you have to script in the console itself. You cannot do any local or remote development with Amazon Athena. So that's how these three capabilities fare against each other at very high level. Now, if you ask me my personal opinion, then how do I see the fitment? This is what I think. And again, it's my personal opinion. So I see that Glue Developer Endpoint is something you might want to use if you want to do local development, like you want to have PyCharm kind of ID running on your local machine, and you want to do a remotely connect to developer endpoint, and you want to perform your Glue job creation. Then you can do then you can use developer endpoint. I see Glue job if you want to like do console-based development, that you want to create your job into AWS console, then you can use Glue Studio Interactive Session. However, if you want to do any kind of ad hoc analytics or query on the data in console, then you should be using Athena. So that's how I see it. So dev endpoint, Glue job development, or even scripting, but from the remote. Studio for Glue job scripting and creating the Glue job, but in console. And Athena when you don't want to create a Glue job, but basically you want to perform some kind of ad hoc, on-demand analytics or query on the data. So again, this is my personal opinion. This is not how AWS positions it. I don't know in fact how AWS positions it, but based on my experience with the three services, this is how I see, in my personal opinion, these three services fit together. So let's learn more about using Amazon Athena with Apache Spark. So what are the steps to configure? Well, there are roughly 3 steps. First, you configure a special work group. So you create a work group in Athena, which is especially configured using Apache Spark as the runtime engine. Then you launch a notebook in Athena to perform such ad hoc queries. And finally, you start using a notebook to write your Spark code and start performing a job or performing analytics. So let's get into each of these steps one by one. So let's start with configuring Apache work group. So now if you try to create a work group inside Amazon Athena, you will find 2 choices. One is Athena SQL, which is so far like traditional way of querying the data using SQL type of query. So so that you can keep selecting for your work group if you want to perform SQL-based queries. But now you also have choice to select Apache Spark as your engine. If you select that option, then your work group allows you to make Apache Spark script-based queries on the data or analytics on the data. So when you configure this Apache Spark workgroup, you have to also mention the calculation location. So basically, when you're running your script, actually a lot of temporary calculations, temporary data is created, and final output data is also created. And you need to provide a location for such data, and that you can configure in Apache workgroup. And basically, you have 2 choices. Either you can ask Apache workgroup to simply create a new S3 bucket, randomly create a new S3 bucket, like create a new S3 bucket with some key name, some token name, and then use that, or you can select an existing S3 bucket as well. You also have choice to choose an option where you can say, I want to encrypt my calculation if you are sensitive about output of your data. So that's how you can configure the location. Now, Apache workgroup, when you're trying to create Apache workgroup, you also need to config service role or IAM role, which Apache workgroup will use. And this service role is very important because it is used to basically give permission to the notebook. Because you are basically using a notebook inside Apache Spark to perform your queries, to perform your analytics, and that notebook needs to have access to the data, whether the data is in an S3 bucket or it has been cataloged and accessed through Glue catalog. You need to have certain permission to access that data, and it needs certain permission to some other services as well. So So this service role configuration is very important. You can use a default configuration, and if you use the default configuration, basically 4 types of permissions it grants. It gives put, list, delete, and get access to certain S3 buckets depending on what S3 bucket configuration you have chosen for the calculation location. And then it gives certain Athena permission. It gives certain log, AWS log, and CloudWatch permissions. But here, a few things which you need to be considerate about. So if you're trying to read data from S3 bucket, it's very important that you enhance this default or out-of-box permissions, because out-of-box gives you permission to certain S3 bucket depending on what S3 bucket location you have selected for your calculated data and those kind of things. But you might have to, you might want to access data from some other S3 bucket, or you might want to write your analytics data to some other S3 bucket. So if you think that, so you might want to go and see the configuration of this this IAM role, this service role, to see what S3 bucket it gives you access. And if you think that you need access beyond those S3 buckets, then you might want to enhance the permission for this service role in IAM in AWS console. So that's the one thing which you should be aware of. Second, you might want to, in addition to querying data directly from S3 bucket, you might also want to query data using Glue database and tables. And in such case, you need certain Glue label permission, a Glue service permission, which is not present out of box by default in Apache workgroup service role. So you might want to add those permissions as well. Okay, so I'm going to also show these 2 things into my demo today, but keep these two things in mind when you're configuring your service role. Now, once your Apache workgroup is configured, then you are good to go and launch a notebook into that, and that Jupyter notebook can then be used for running any kind of ad hoc query you want to run on your data. So for that, you need to configure certain things for your notebook, which are very important, because it actually it converts into a cost for you and also performance for you. So you need to know certain things. So first of all, each notebook you might want to, so when you run a notebook, basically you're running a notebook session. That means your notebook is in use. So you might want to set up some idle timeout period that if your notebook is not in use for certain time, then after that the notebook session will be considered idle or should be auto terminate, because you don't want to keep running a notebook if you're not using it. And you can mention that timeout you can mention the timeout in minutes. Then you can also configure coordinator size. So basically what this notebook is using is an Apache cluster behind the scene, which is created for you. So basically what you can do is that you can select a configuration called coordinator size, which is like a leader node or orchestrator node. And right now you can only select 1 DPU for such orchestrator, and this is the default value and the only value. Probably in future you might have a choice to select a larger capacity. Then you can also select your executors or the compute units which are actually going to run your queries. And basically, this executor is considered like smallest unit you want to ask. And right now, the smallest compute unit you want to you can ask is 1 DPU. And again, this is the default value and the only possible value at project. So keep this in mind. This is the smallest compute unit. That means if you want more than 1 DPU, you can go for more than 1 DPU. So how do I go for more than 1 DPU for my compute? For that, you have to select a concurrency value. So executor is simply saying that, hey, this is the smallest compute unit you can ask for your notebook. But then you can select how many such such compute unit can run in concurrency. So for instance, that's also you mentioned in DPU, and default value is 20 DPU. That means your executors can go up to 20 DPUs in concurrent run. So you can select a value between 3 to 60, and default is 20. So when you select 20, it doesn't mean that it will always use 20 executors in parallel. It means that it can go to up to 20 executor in parallel, but how many executor it selects to run in parallel depends on what kind of data you are querying and what kind of compute you need for such data. So as I mentioned earlier, that it is very important we select, I mean, like right now your coordinator and executor are fixed to 1 DPU. You can't do much about it, but concurrency is something you can change any value between 3 to 60 DPUs. And that is very important because when you select your DPU, basically you're telling Athena how much DPU it can use, and depending on how much DPU it can use, basically you are billed, okay, and you are billed 35 cents per DPU hour. I should have mentioned hour over here, per DPU hour, and it is billed per second. Okay, so keep this configuration in mind when you are trying to configure your notebook. So few more things to know about notebooks. So you can always start and terminate your session. So you're billed only for the session time in your DPU. So if you want, you can start a session and then terminate a session, or you can set up an idle time, and after the idle time, the notebook will automatically terminate. You can export and import notebooks. So you can create a notebook with certain scripts in mind, and then, hey, I want it to give it to someone else who can use it. You can export it, and other guy can import it in his or her account. You can do that, and also supports API. That means you can create, you can call APIs to create a notebook or configure a notebook or start or stop a session. Okay, so keep these other things about notebook. So having configured notebook, now you are good to go and start performing analytics using Apache Spark. So or Spark scripting. So first question comes in mind that, okay, I'm running this inside notebook. So what are the out-of-box libraries, Python libraries, which are present in this notebook? Okay, so what is already there which I can leverage? And this is the list of different libraries. You can see here all the way from Boto to Cython to NumPy to Pandas, Matplotlib. These are or scikit-learn. These are different libraries which are already available in notebook out of box, which you can use to perform your query or perform your analytics. But you are not limited by these libraries only. If you want, you can also import external files or external Python libraries. I did not go into this part much in detail because otherwise video could have been much bigger, but I want to just point this out to you that you do have option to work with libraries outside the out-of-box Python libraries. Okay. Now, when you are running different types of queries into your Apache Spark, into your notebook in Athena using Apache Spark, then you might be interested is that how long this particular statement or script is taking. So you might want to see calculations around different execution, how much DPU it is using, how long it run this particular statement. You might be interested in those kind of analysis because it gives you indication about the cost of your query, about performance of your query. And that is possible because when you are running the notebook session and you're running different scripting, for each script it actually stores the calculation of that particular script, and this calculation will tell you that whatever script you run, how much TPU it used, how long it run, and other kind of information. So keep this in mind, guys, that each of the statements or scripts you are running inside Athena using Spark, you can see the calculation of those executions, which is pretty cool in my opinion, because I can look into the cost of my statements. Now, you can work with different data formats in Athena, and these are the list of different data formats and what kind of read or write operations you can perform with these formats, what kind of compression algorithms it allows. Here is the comprehensive list which I found on AWS documentation, and it's for your information, always to keep in mind when you are working with different types of data formats in your analytics platform. Okay, so there are few limitations at present which you should know. So right now it does not support AWS lake formation. So if you are setting up any kind of access rights using lake formation, it does not support that. You cannot, so you can access cataloged data, but you cannot access any view which you have created using Athena SQL. So if you create any view using Athena SQL, that you cannot query in Spark. So Spark works with S3 data directly very well. It works with Glue catalog very well. But if any Athena SQL based custom view you have created and you want to access that, that is not possible. That is not supported, and it does not support Apache Spark ML library at this point of time. So there are a few limitations which you should know. And then it's time for a demo. So what I'm going to do is that I'm going to use Amazon Athena with Apache Spark to query data from S3 bucket. And this data I have also cataloged using AWS Glue data catalog. So I'm going to show both Glue catalog and Amazon S3 direct query or analytics method. So let's go to AWS console. So here we are in AWS console. Let me show you a few things. So here is my sales data. So I have a sales.csv file, which I have simply put into Dozo my data sales folder. Okay, so this data I'm going to use for query. Now I also have an output folder in the same bucket, and this location I'm simply going to use to put any output file if I want to generate. And right now you can see this folder is empty. Now if I go to AWS Glue console, you can see here that I have cataloged this Dozo my data sales.csv file, and then this is how the schema of my data look like. So I catalog the data so that I can show you that how you can use Apache Spark with Glue catalog for analytics purpose. And here I have also Amazon Athena open. So let's get started. So first thing first, I need to create an Athena work group. So for that, I will come to the left hand side in this work groups menu. Right now I have out of box primary work group. So let me create a work group, and I will call it say Apache Spark work group. Okay, you keep it simple here. You can see I can select two options over here. Now I'm selecting Apache Spark. Now I can use my default configuration over here, which will simply create a service role for me, which is owned by Amazon Athena. And then it will automatically create a new S3 bucket for me where my calculated locations can be shown, and few other configuration like push matrices to CloudWatch or not. So I don't want to change any of these things for now. So I will use by default configuration, but you do have a choice that you can change this toggle button, and you can actually go and modify each of these configurations. So let me create a work group with default configuration. So now my work group is created. You can see here. Let me open the work group. All good. Now this is the location S3 bucket which it has created, where it's going to store my calculated data or calculated results. You can see it has simply created a bucket with some token number or token name over here. This is the IAM role or service role it has created. Now I need to change permission of this IAM role because I want to read data from some other S3 bucket locations as well. So let me click on this particular role link over here and let it open in AWS console. And there I want to simply go and modify the permission of my role. So you can see here that my role is open in AWS console. Here is my policy. Let me click on the policy as well. So it's opening up the policy for me. And it should take should happen any minute now. So yeah, you can see here my policy has been opened, and you can see here if I edit the policy, then I can probably show you better. If I click on the edit button and if I go to my JSON, you can see here that it has got all those permissions I was talking about. But now if you see, look at the S3 bucket location, it has permission only to that calculated location, nothing more than that, which is not going to work for me because in my opinion, in my case, I want to read from more S3 buckets and I want to write data to more S3 buckets. So ideally what you should be doing here, that you might want to add more S3 bucket locations over here, where you want to read and write data from. But for now, I'm super lazy guy. So what I'm going to do, that I'm simply saying that, hey, I give this permission to any of the S3 buckets. So basically I'm giving these 4 permission across all the S3 buckets, so I can work with any S3 bucket I want. But ideally you should not be doing it. You should be adding your S3 bucket location which you want to use for querying data or writing data. Once I have done that, you can see here there is no glue label permissions, which I'm not liking because I want to query data from glue. So I will add some permissions for glue. Now in glue also you can be very selective about what permission you want to add. Like you want to able to query certain databases, certain table only, or certain kind of operations on those tables only. You can go that restrictive, but I'm not going to do that again just to save time. So I'm simply saying that I give to all the resources this glue star permission. So I'm giving glue like super permission for glue across all the resources. Again, not a best practice, but I'm doing it just to save time. But you should, when you're doing it, you should be giving a particular access to particular resources only. So now my JSON has been modified. I have added a kind of access to all S3 data, and I have also added glue permissions over here. Now I can review this policy. Okay, there is no error, and I can save changes. So now my S3 bucket permission has been modified. I'm all good. So now I can go back to Athena, and here I want to create a new notebook now. So I can go to my notebook explorer here and say I want to create a new notebook. Let's call it Dozo demo notebook, and it asks you to select the work group, and I'm simply providing it this work group name. And you can see here I can provide it more capacity, like what is the session timeout, coordinator size, executor size, and maximum concurrent values. But I'm simply keeping it default, and then I am simply creating the notebook. Now my notebook should be created in no time. So yeah, here we go. My notebook has been created, and not only created, it also started a session for me. Here I can simply go and end my session, or I can terminate my sessions. I can do those things from here. But right now I don't need to. I want to run some commands over here. So first of all, when this notebook session started, my my Spark session is already created. So you don't need to create any Spark session. Spark session is already created for me. So I can simply go, if you want to see that I want to print this Spark session, let me print it, and it will show that, hey, my Spark session is already created. You can see that. So now let me try to do a few things. So let me try to read data from S3 bucket directly. So I run some code over here. What I'm doing here, I'm saying, again, I'm using Spark scripting. So I'm saying spark.read CSV. This is my CSV file. Please infer my schema, and I have a header row, and then populate that into this data frame. Okay, so let me run this statement over here, and when I do run this, actually it is going to populate my data into this particular data frame. So while it is populating, I can do the next step, which is I want to show this data. So let's say df.show. I want to see what data is there. So let's run it, and when I run it, it shows me my data frame data in a tabular format. So let it do that. Okay, so you can see here it's showing my data in the tabular format. So it's like running Apache Spark in Notebook. Right? Well, it's Apache Spark in Notebook. Only thing you're doing it from the Athena console. Now what I can do, I want to perform some simple transformation. So say I'm not interested in all the columns, but I also only want order, number, and sales, these two columns. So let me filter down. Let me do column-wise filtering of my data frame for these two columns only. Let's run it. So I did that. And then I want to see my data. So if I come over here, say df.show again, and it should show me my data frame again, but it should show me only two columns. So you can see here that it's showing only two columns, which I selected. Now, suppose this data frame I want to write to S3 bucket. So this data frame which I created, I want to write it back to S3 bucket. If I want to do that, I can run a statement like this, where I'm saying df.write in CSV format. This is my location. So in output, create a CSV folder, and in that put my output data, or CSV object, and put my output data. So if I run this statement, basically it is now writing back my data frame to S3 bucket. So it should be happening there any minute now. So you can see it wrote it back to the S3 bucket. Now if I go to, in fact, my Dojo output, and if I refresh it, you can see it has created a CSV folder, and under that you can see there's a CSV file, which is how the output file look like. So I'm not going to open it, but yeah, it works. Now let's see how, if you don't want to work with S3 bucket directly, suppose you want to work with catalog, then how you can do that. So remember, we have already cataloged the data. So we have this sales data in Dojo database, the same data, but it's cataloged, and I want to suppose use catalog for my analytics purpose. Then how do I do that? So for that, I'm going to use my Spark sentences for Hive Metastore. So I simply say spark.catalog, set my current database to Dojo database. That's a database I have in my Glue catalog. I'm setting my database location, and now once I do that, actually now I can simply run a Spark SQL query saying select star from sales. So same thing, but I'm using a SQL query now in Apache Spark. And then if I show my data over here, you can see that it's loading my data again, but this time using the catalog. So it should be there any moment now. Oops, yeah, here we go. So it shows the output. So you can see how it you can run your Apache Spark, full-fledged Apache Spark scripting in Athena to do ad hoc analysis of your data. Now, one thing to keep in mind, that suppose I want to know these different statements I run, what was the cost of running that statement? What is the calculation behind it? So for that, if I go to my notebook editor, oops, not here, sorry, notebook explorer, I can select my notebook. Then I want to say, show me my session history. It shows here right now there is one session which is running right now, which I'm running right now. If I go over there, basically it shows different queries I have run. So for instance, if I click on this one, it is showing that I run to set database basically, and it took it took 2.5 seconds, and these were if I show the result. Yeah, okay, I can see that. You can see the output in S3 result. So whatever temporary data it has created, you can see that in the S3 bucket, and this is the code I run. So now let me do one more thing. If I do that and say, okay, suppose this one. And in this one, you can see here that I'm trying to read data, and if I see the result, it goes over here. So you can see that it shows you that how many seconds it run. And what is the DPU it used actually? Well, it's not showing me. I think I can if I go to my probably in my CloudWatch, I can see more information about DPU because what I'm not finding here on the screen is that how much DPU it used actually. It shows how long it run, but not showing how much DPU it used. I will do one thing. I will do some investigation on that, and I'll make a short video about that so that I can give you that information. But that is how basically you can do ad hoc query on your data using Apache Spark, using Athena. Once you are done with your work, you can always go to your sessions and say, hey, I want to terminate the session. And when you terminate the session, your session ends, and you don't pay any more for your DPU because your notebook is not in use at all. So that was all about how you can use Apache Spark with Athena to do ad hoc analysis on your data using Spark scripting. Hope you like the video, and if you like the video, please click on the like button. Please subscribe to my channel. I promise to come back again in a week's time with another such video, another such tutorials. In the meantime, please stay safe and have a nice day. Bye-bye.